Good afternoon. Today we're going to talk about combining resistors to get a value that you don't have in stock or isn't made. There are two ways of combining resistors to get different values. One is putting them in series, so they're one following the other. The other is putting them in parallel where they are connected across from each other. In the series, you're combining two resistors to get something a little bit bigger than what either resistor is. And this one comes out very simple. You know what your total resistance is supposed to be. You have one resistor. You can find the other just by adding them together. So this one becomes a fairly simple situation. The problem comes in is if you have something and let's say your first resistor is too big to begin with, so you have to make it smaller. How do you determine how to make it smaller? Well, the combination has an equation very similar to the series. It's the 1 over the total resistance is equal to 1 over R1 plus 1 over R2, and so on for as many as you have. But that is a major hassle to deal with this equation. So without going through the math, we've changed it. Your total resistance is equal to R1 times R2, that quantity divided by R1 plus R2. It's a fairly standard parallel thing, but that will tell you if you have the two resistors and you want to find out what the total is. Usually you have one resistor and you're looking for this. So I've rewritten this equation here to say what is R2 if you know what R1 is and what your target is. So this one would be R1 times RT, the total, divided by R1 minus RT. Bear in mind that your equivalent resistance is always going to be smaller than either one of the resistors. To use as an example, we take as an example what we are going to do is take, that's maybe the only smallest value you have. That'll be the smallest one we have, let's say in stock. We want to create a 2.0 something. Let's say 0.10 ohm. Well, so the first thing we're going to do is 4.7. If I connect two of them, the smallest value we have is 4.7. So if I put a 4.7, that's 2 of them. That divides by 2. This calculation is easy because it's half the value is equal to 2.4.75 ohms. That happens to come out. We're not there yet. 2.35 ohms. Still not close enough. Take this combination. So we use this bottom equation here. Two resistors together already connected. We'll treat it as one resistor. Run this equation out. And our total being we find out that 2.35 minus 2 right around what we end up 11, with 12 ohms. 4.7. We use 10 ohms parallel. That's all we may have. 4.7. What we want to parallel it with. The equation comes out to 13.43. Combination again now parallel with 10, which equals now 2 ohms. They don't make a 13.43 ohm resistor. So we'll take this value here, 2.3 ohms, 2.35 ohms, and we will find out we have two values. We can use 10 ohms, because that's on one side of 13, 2.35 parallel 15 ohms, and let's see where we go. We're going to use this equation now. This one comes out to 1.90. Pretty close. We run this one out, and that comes out to 2.03. Actually closer, so we want 4.7, 4.7, and 15 to give us 2 ohms. This is a good example and a fairly common one here. Okay, so today we discussed, thank you for being with us today. The value of resistance, how to combine resistors in series, how to seriousing the resistors, or reducing the value of a resistor by paralleling it with one or two resistors. We have the equations for series. We have the two equations you need for parallel. So we will see you next time.